let's now create some formula for geometric series. So there's our sum to n, but written out with all its terms. So a, ar squared, and so on and so on. I'm going to rewrite it, similar to how we did it with the arithmetic one, but this time, not just rewrite it, multiply it by r as well. So the a becomes ar, the ar becomes ar squared, and so on. You'll notice I've shifted it across to kind of make it a little bit more obvious why I've done that. Because now you've got all these middle terms that will cancel out when I subtract. And I'll just be left with the two n terms. Now, which way around am I subtracting? Well, it doesn't really matter. I'm going to do the bottom one minus the top one and get r minus 1 lots of Sn is ar to the n minus a, divide by the r minus 1, and we get our formula. And we tend to use that formula when the ratio is bigger than 1. Now, remember I said it doesn't really matter, because if I had gone the other way around, then I would have ended up with the formula of a, 1 minus r to the power of n over 1 minus r. And we tend to use that formula when the ratio is less than 1. Now, it doesn't matter which one you use. You can use the first one if the ratio is less than 1, and you can use the bottom one if the ratio is bigger than 1. It's still going to work. It's the same formula. Because if you look at the two formulas, all that's really happened is top and bottom of the fractions be multiplied by -1. So of course it's the same ratio. And I guess the reason we do it is simply so we get a positive number on the bottom of the fraction, assuming the ratio is positive. That's the only logical explanation I have for why we traditionally do it that way. Okay, let's have a look at this one. 2, 6, 18. Let's confirm it is geometric, yes. 6 divided by 2 is 3, 18 divided by 6 is also 3. So we're going to find the sum of 10 terms. So let's sub in. Now, calculators have got better and better over the years. So you probably can bung that all into a calculator and come up with an answer. But we should end up with 59,048 in sigma notation. Now, I know it's geometric because we've got an exponential function here. The independent variable is in the power. So it's got to be an exponential. So I know I can use my geometric formula for this, but notice the first term. It's n equals 3, it's not n equals 1. So the first term is actually 6 times a half squared, which is 3 on 2. Now the ratio is still going to be a half. That's not going to change because it's ar to the n minus 1. That's still fine, but if you don't believe me, you could always work out what the second term is and go, oh look, what's the ratio? There we are. And the number of terms, starting at 3, finishing at 8. 6 terms because it's inclusive of both ends. So subbing in, fractions on fractions. Again, it depends on how good your calculator is at handling something like this. You might want to do the half to the power of 6 first. I've done the denominator separately as well, you'll notice. And I've gone 3 on 2. Then inside the parentheses we end up with 63 on 64. Invert and multiply the bottom, I've got 2 on 1. And that all cancels to be 189 on 64. Why do I do it that way? Because I'm old. And I'm used to calculators that can't quite handle all that in one hit. And so I tend to do the operations. So, you just play around with your calculator and see what it handles, I guess. Okay, 1G, that'll do us.